know this is a lot of information. This is supposed to be given over 2 days, so I'm just going to give you the lecture all day today, and you can just kind of practice tomorrow. Okay? So, implicit in Calc 1. Okay? If I gave you a problem like this, let's see if we remember how to take the derivative dy dx. So in Calc 1, again, this is just Calc 1. Okay? We're taking the derivative in terms of x. So the whole thing, if you remember, was we always were saying 3y squared, and anytime you touch a y, you would say dy dx. So plus 2y dy dx minus 5 dy dx. Finally, when I get to an x, I can just say minus 2x. And the whole reason is you could say dx dx. What's dx dx? 1. So I never need to say that. I just say negative 2x. And the derivative of 4 is nothing, so that equals 0. And if you remember, we would then go 3y squared dy dx plus 2y dy dx minus 5 dy dx equals 2x. And if I factor out the dy dx, I have just the leftover stuff here. And I can finally divide over and say 2x over this stuff. And there's the derivative of y with respect to x, Calc 1 style. Now, Calc 3 makes it a little bit simpler as long as you know a formula. I'm going to show you how the formula happens, but then from here on out, know the formula. Okay? So, in Calc 3, I want you to think of it as this. I'm going to first call, I have this guy W, and he breaks up with an x and a y. And x is all about just x. So you might go, why am I putting that branch? Just hear me out. And y is about x. So in our previous example, I'm calling everything here my w. Everything, you couldn't see that because you can't see what I touch on the screen. Everything there is my w. And every single time I need to make sure my w part equals 0. So the whole time I'm going to always tell you w has lots of x's and y's in it, but it always equals 0. Okay? So if I set this derivative up, I can say for this derivative, dw dx is the partial of w over the partial of x times dx dx. Now notice, the first guy was a partial because it was coming from a split, and this guy is a full because it's only connected to himself, plus the partial of w over the partial of y, that's this part, times dy dx. And that's a full again because it's only one connection. Well, let me just make sure you're okay with this. What is dw dx always in this case? If I'm saying w equals 0, then dw dx has to be 0. So look what happens when I simplify this. I have 0, oops, there we go, 0 equals the partial of w, partial of x. What's dx dx? What is that? It's 1. Plus the partial of w over the partial of y times dy dx. Well, if I want dy dx, I can just solve for it. dy dx equals, let's see, it's going to be, I move that one piece over and then I divide. So I got the partial of w over the partial of x all over the partial of w over the partial of y, but one of them is negative. I just kind of skipped a step or two to make sure I got dy dx by himself, so hopefully you're okay with that. So this is a formula that I can do to get dy dx through kind of partial ideas through Calc 3. Notice, I know there's a lot of terminology there, but it's dy over dx. Notice how there's a negative, and then there's a partial with x on top, and there's a partial with y on bottom. So what kind of happens is that goes up and that goes down. And that's always the case with the attached negative. So if I take a look at that, same exact problem. If I want dy dx, it's a negative, and it's the partial of w with x on top, the partial of w with y on bottom. Look how quick this goes. Well, the partial of x is just -2, and the partial about y is this 3y squared plus 2y minus 5. Okay? So immediately I can tell you dy dx is negative of the negative 2x all over 3y squared plus 2y minus 5. Now implicit took a long time all the way through Calc 1, but now if you can handle partials, it's super quick. So now I have, it's just 2x over 3y squared plus 2y minus 5. Okay? And it's that quick and that simple. Okay? If you remember, if I ever gave you one of these problems, Calc 1 kids always struggled with these. If I made it something like, let's say x squared plus 2xy plus y cubed equals 0. And I'd always want you to do implicit in Calc 1. And the thing kids struggled with was that was a product rule. Well, now, if I want implicit, it's going to go pretty quick because I say dy dx is negative, the partial with x on top, the partial of y on bottom. Okay? Now look what happens, how quick this is. I'm going to just do it all basically in one line. Negative. Okay, the partial of x, 2x plus 2y, all over partial of y. Okay, partial of y is just, oh, whoops. Mr. Bach is getting tired again. Mr. Bach is extremely tired. That is actually right. Sorry guys. And then the partial of y would just be 2x plus 3y squared. And I'm done. Just like that, you can do implicit all in one line now, even if there was a product rule involved. Okay? Doesn't matter how complex that product rule is. As long as, again, your whole thing is you make sure it equals 0. That's the key to that. And you can always move something over to make sure it equals 0. But that's how you can do implicit very quickly in Calc 3. Now, I only have one more to go with here, and it's actually a pretty quick one. Okay, so let's take a look at it. I'll tell you now, there's partial derivatives implicitly, and I'm just going to give you the formulas. Okay, it's going to be the same idea. So if I ever say the partial of z over the partial of x, okay, I want you to make sure you think of that as there's a negative, there's some partial of x all over some partial of z, and I could also give you the partial of z over the partial of y would be negative, some sort of partial with y on top over some sort of partial with z on bottom. Okay? So, if I look at it, let's do the first one here. I want that guy. So the partial of z over the partial of x is negative. Let's see, which guy do I need up top? the x guy. So I'm going to take that guy's derivative. Well, the derivative of 3x squared z is 6xz minus 2xy squared. And there's no more x's, so that's all I need on top. All over, well, let's see. Now I need to do the partial of z's. So that's going to be 3x squared. The next guy's x's and y's, so there's no z's there, plus 6z squared plus 3y. And I'm done. That is the partial of z in terms of the partial of x. Okay? And if I want the partial of z over the partial of y, okay, negative, I'm going to do the y guy on top. So I get negative 2x squared y plus 3z all over. Now I'm going to do the z guy on bottom, which we are going to have 3x squared plus 6z squared plus 3y. And there's your partials based off implicit. Again, remember, all you need to do is, if I ever say z over x, there's a negative, I put the x guy on top and the z guy on bottom. That's a z. So there's kind of that crisscross. Okay. So hopefully you're kind of feeling okay. I know this was a lot of notes, and I apologize. This would have been done over 2 days. But you have all the notes, and so today and tomorrow, pace yourself out and see if you can get through the work. I'm telling you, if you can draw a chain and you can understand which guys are partials and which guys are fulls, you're going to be okay. Draw the chain first, set up what the formula is, and go from there. Notice, the formulas change for every single chain that you have, but it's the same sort of pattern. So here's the homework, and I'll see you guys on Monday. Hope you have a good weekend. Be safe at homecoming. Enjoy yourself, but please be safe, and I'll see you on Monday.